Hi guys, today I'm going to talk about type 1a supernovas. Let's start with learning about what is actually a supernova. So a supernova is explosion of a star. It is a large explosion that takes place in space. Now you might ask yourself how learning about them is useful for scientists. Well, the reason why is that when the star explodes, it shoots elements into the space. So many of the elements we find here on Earth are made out of the core of the stars. These elements travel on to new forms to form new stars, planets, and everything else in the universe. So there are two main types of supernovas. We have type 1 and type 2. So type 1 supernova is distinguished from type 2 by the lack of hydrogen lines in its homogeneous spectrum. The presence of other lines in the spectra further divides the type. So one of them is type 1a supernova that we're going to talk about. So this supernova occurs in a binary system where one star is a white dwarf and the other is a star that can be of giant mass to even a smaller white dwarf. Normally restricted to less than 138 solar masses should be a white dwarf of oxygen-carbon variety. Exceeds it, then the nuclear fusion may start up again. The mass is obtained by the accretion of material from its binary companion. If accretion continues for a long enough period of time and a nova or a dwarf nova does not occur, the star will approach the limit. So we have the type 1a supernovas that can occur by two scenarios. So the first one is going to be the single degenerate, that we're going to have a main sequence binary which has two stars in it, and then one of them is more massive and revolves quicker. And then we have the evolve binary where you're going to have the more massive star leaves the main sequence first and becomes a white dwarf. Stars share a circumstellar envelope, and mass loss decreases the angular momentum and orbit shrinks, and the second star becomes a red giant. And then we have the accretion where the white dwarf accretes matter from the red giant, and then the mass of the white dwarf approaches the limit. And then we have the carbon ignition, which increases in mass, raises the temperature, and then which is hot enough for carbon fusion. And then because of the degeneracy, pressure is independent from the temperature. The white dwarf is unable to regulate the fusion in the way that the other star would, which results in a runaway thermonuclear reaction. And then that's when we're going to have the type 1a supernova. And then we have the other scenario, which is a double degenerate. And then we have the main sequence binary, which we have two stars that have the same mass and they evolve at same rate. And then we have the white dwarf binary, and then the stars evolve into white dwarfs. And then we have the orbit decay, which orbit decays over time due to gravitational radiation, and then it becomes extremely small, and then they merge together and the combined masses exceeds the limit, and then that's when again we're going to have an explosion and the type 1 or supernova. So type 1b and type 1c are the other types of type 1 supernovas that are similar to mechanics of type 2 supernovas, although like type 1a, they lack in hydrogen lines. They occur due to core collapse of supermassive star. The collapse of the star's core expels the outer layers. Type 1b and c are thought to have already lost their outer hydrogen shells and much of their helium shells. Type 1c supernova happen to lack the helium lines compared to type 1b. Both show calcium, oxygen, and magnesium lines as they age, while type 1a are actually dominated by iron lines. That's it for type 1 supernovas, and I hope that taught you guys something new.